So I'm rethreading the line, and it's a synthetic line in this case, back into the drum. And I need to knot the end to prevent the line from being pulled back out once the winding begins. This is the maintaining power system that James Yule built in the 1800s, and I believe he was influenced heavily by the Harrison model. So the Harrison model has been described as a disc fitted with springs that is actually placed between the drum and in the driving gear. And in the last video, you'll have seen this more clearly as I actually assembled this piece. Right, so with the line passed through the drum, I need to knot it. And I'm using a double knot, as I know if the line becomes slack, it won't unravel. I've left a long end on the knot so as to prevent it from popping out of the axis hole. Placing the gears in order on the going side, that's the right hand side as we look at it on the video, is fairly simple and straightforward, and the only real function they have is to provide power to the escapement. The side on the left, that's the strike side, that's a different situation. So the gears on the left, that's our strike, and they have a very, very particular order in which they're placed. So the gear's orientation to one another is key in relation to how the strike functions. Now that I have the order and orientation of all the gears correct, it's time to fit the top plate, which I'll cover in the next video. Thanks for watching.